Right. Right. In thermal conductivity, not thermal conductivity value is equal to infinity in case of perfect conductor. K is equal to 0 in case of insulator. Okay. Next to write temperature gradient. Temperature gradient is what? Change in temperature divided by distance or displacement or length, anything with a gradient, temperature gradient. Now for this, how to find the temperature gradient? Already we know that Q is equal to, from the formula, Ka into delta theta into T divided by dx. So this delta theta by dx is the temperature gradient. Now if you want, then other directly can write, so d theta by dx is nothing but theta 1 minus, so theta 2. So theta 1 minus theta 2 divided by L is called temperature gradient. So what is the unit? So unit is, this is the degree centigrade per centimeter. This is a CGS system. Okay. Kelvin per meter in SI system. SI system. So this is the temperature gradient. Now other units also is there. What are the other units? From this you can make it the another formula. This is the formula in case of temperature gradient. The other unit what you are going to get? D theta by dx. Now I want to take other unit. Cut it off. Q by T called a power. So other unit I can write it as, this is a watt. Okay. Now here is what you call again K is there. If you use the Kelvin unit, what you call thermal conductivity unit, finally you are going to get thermal conductivity unit and the area in meter square. Finally you are going to get what? Same unit only. What unit you are going to get? So Kelvin per meter only. So there is no other unit. So other again, if you simplify it, it is called SI system unit is same unit. Even though if you try it, you get Kelvin. What you call to say this is Kelvin per meter. This is called Kelvin per meter. So this is called temperature gradient. Next, write please. Okay. Next, go to right. Next, go to right. Now, relation between temperature gradient and thermal conductivity. Relation between temperature gradient and thermal conductivity. Thermal conductivity is called K. This is the d theta by dx. So d theta by dx relation. Now, what relation are you getting? So it is very simple. From the basic formula only you are going to get. As you know that Q is equal to Ka into delta theta into T divided by L. So this we want to. Here Q is constant, heat flow is constant. K, what you call, we want to talk about this and this only. So area of conductor is constant, cross section, time of flow also keep constant. Now what relation we are going to get? D theta by L into K is equal to constant. Then I can say d theta by dl or dx is equal to 1 by k. 1 by k. So this is the relation between temperature gradient and thermal conductivity. Temperature gradient and thermal conductivity. Okay. This is my thermal resistance piece. All of understanding up. Then go to thermal resistance. Go to thermal resistance. Right. Thermal resistance, you can say RTH, thermal. So thermal resistance. So Q is equal to Ka into delta theta into T divided by L. But as early we know the resistance formula. Thermal resistance, I am going to the basic formula. So already we know that resistance formula, resistance R is equal to rho L by A in current electricity. So this place what I want to do, we want to rho L by A. Now these two things I take to denominator, so Ka. So it won't affect the formula. So this is called thermal resistance. So thermal resistance RTH or R is equal to, so we can get 1 by K into L by A. Okay na? We call thermal resistance. Right. We want to write the unit here. We want to write unit. How to write? So this is thermal resistance. Now I will bring this fellow to here. Now thermal resistance R is equal to, what is the remaining? Delta theta. That I can take, this is a T to this side. This becomes power. Now here I can take power P. The unit is what you can say, degree, the Kelvin per watt. Kelvin per watt. Kelvin per watt is the unit. Right. The unit is very easy to write. So Kelvin per power unit watt. So that means thermal resistance with respect to power is R is equal to delta theta by T. So this, so thermal resistance with respect to thermal conductivity, question thermal conductivity is RTH is equal to 1 by K into L by A. And with respect to power is R is equal to delta theta by T. If you know power, you can find this one, temperature difference. So that is the units. So it is the thermal unit in terms of what you call the Kelvin or what is the SI system only. SI system. Okay. Now, so you got power also. Power. Now power or you can say rate. Power you can say or rate of heat flow, both are same only. So this is you write power or rate of heat flow. Power or rate of heat flow, you can say H is equal to, so what you are going to get? Delta theta, temperature difference divided by resistance. Temperature difference by resistance. So unit of what the power unit is? Watt. Joule per second or watt. Joule per second or watt. Okay. Right. Next, more right. Next surveying, next concept. Thermometric conductivity. Thermometric conductivity. OR diffusivity. OR diffusivity is right. Most important is the chance to ask this formula only. Okay. Thermometric conductivity. Thermometric conductivity. Another name is OR diffusivity. D-I-F-F-U. Diffusivity. Diffusivity D. They will show to ask formula. Okay. Now see the right definition. Definition please. Write a definition. diffusivity is defined as diffusivity is defined as diffusivity is defined as the ratio of the ratio of the ratio of the coefficient of thermal conductivity the coefficient of thermal conductivity to the thermal capacity per unit volume thermal capacity per unit volume thermal capacity per unit volume thermal capacity per unit volume. So this is the thermal capacity per unit volume. Okay, now what it is going to happen? Now I am going to write diffusivity D is equal to thermal conductivity per unit volume. This is called thermal capacity per unit. Mass by volume gives you density. So K divided by this gives you rho C. See the specific coefficient of specific heat capacity. So that is thermal diffusivity formula. Right. If you want to write, where C is equal to specific heat capacity, coefficient of specific heat capacity. Then you are writing S, now here also writing C, you are writing specific heat capacity. So this is called diffusivity. Now the unit, what unit you are going to get? Is unit is meter square per second. Meter square per second. Right. Complete it up to here.